Welcome back. Today we are going to look into functions. Okay, important topic for you. So, need more of your attention. And in the context of functions, we will start looking into stack. I will explain different cases. For example, the very first case that you're seeing here is the case we would have a function here which doesn't have any arguments and it doesn't return anything. Okay. So gradually we will build on top of that. I think there are 4 or 5 cases I'm planning to mention, and gradually we will make some of the execution steps within the function in assembly solid or more mature, how it should be. Okay, and as we go through different cases, we will learn something new every time. So today we're going to look into 2 cases. So we have here a main function in C. Okay, this is the one, it's calling another function inside. So that function is simple. The name of it is simple. And that function is defined here. So you know why we define function in C or higher level languages, right? If there is a bunch of code that will be repeated so many times, so instead of writing every time different code, we just define it once. So later on, if we have to change, we just have to change one function code if you want to make some improvement or you want to add something, then all those calls that we make here for that function, will have those updates or changes executed. So that's the benefit of it. Okay. So this function is a callee because that is being called. And the caller in this case are main top level program. Makes sense so far? Now this is just an example here. Of course, you will, if this function doesn't anything, doesn't return anything, doesn't take anything, what's the point of this one? But this is just for an example initially. Okay. So this is the corresponding assembly for this thing. So what we have, and let's say address 300. I mean, these are 32 bits. So each one is 4-bit. This is hexadecimal. So I'm not mentioning the other ones. At 300, we have here. That's the only thing inside this program, right? So what we call this instruction, JAL, jump and link. So what it's going to do is going to do these 2 things. So first of all, it's going to make a jump to that function that I mentioned in number 2. So definitely we need to go to the code in memory where we have definition of that function. Correct? But before we make a jump, let's say there are a few other things in this one which I'm not mentioning here. Actually, the next instruction is at this address. You know that every 32-bit, every word is this plus 4 because it's byte addressable memory, right? Okay, so before it makes a jump to simple, it needs to put the next execution instruction address into this register RA. So if you remember, some of those registers that I had mentioned during the register video, there were a few very special registers. Their purpose was special. RA is one of them. It means as it stands for return address. So it keeps the return address so that when it makes that jump, and when it finishes execution, it goes back and start executing from here. So first thing it does is go to jump, but before jump, save the return address in RA. That's what this JAL instruction need to do. So in this very simple case, we have a simple, which is simple function. We go here. So ideally when we convert this into machine language, we need to put address here, 51C. So at 51C, a function is defined, and a function doesn't do anything. All it does is it returns. So it goes there and we go back. So for that jump, when it's coming back out of function and going back to this line, that instruction is JR. what it does, it jumps to the address stored in this register RA. And remember, we stored which address? This one. So all we're doing right now, we're not doing any action within this. We just go there and come back. So we come back here. Good. So far, so good. So as you've seen that there's no point, there's no argument, there is nothing done and return value. So that is the next level we're gonna add, and I'm calling this case 2. So function will have an arguments and it will have a return value. Now remember that A0 to A7, these are the registers which are used to keep the arguments that you pass to the function. We will look at later on if arguments are more than that, what happens. But right now, assume that the maximum arguments we can pass to the function are 8. A0, 1, 2, 3, 4, 5, 6, 7. Now our little intelligent function is something like this. So a main program is main. I'm taking these examples from our reference book that we are following. So we define an integer y, and we have a function diffs of sum, and we pass it 4 values, 2, 3, 4, 5. Function does its work and returns a value that we stored in y. The function is this, the definition. You can see it returns an integer, and then definition is that first value is, we call it f, g, h, i, each one is integer. We define a local variable. So some of this variable is a global variable, it's a main program, right? But this one defined as a local variable. And you will understand more of what these local variables mean, why local variables are gone when we come out of function and all that. Okay, so I think some of these concepts will really help you in a better understanding of some of the C code that you've been writing as well. And what we do is this result adds f and g, h and I, and then the difference of the two sums. It put that in results and return that value, which eventually we store in y. Okay, now this is the assembly version of it. So as you can see, now we have some action done here. We pass some arguments, return something. So before I said that the argument, so once we call this function, well, let's say once this is called here, JAL, diffs of sums is defined here. And here in the last one I put RA, but I think I skipped this one. We will look at these are kind of pseudo instruction. They contain several assembly instructions inside, but I'm just giving it the function name, and it's understood that this instruction is going to put the next instruction address into RA before it goes to that function. But the function, we are passing 4 arguments. So where are those arguments kept so that later on function can read it from there? Okay, so those 4 arguments, A0, A1, A2, A3, these are the 4 registers in our register set, each one 32-bit. That's where we store that values. So F get 2, so 2 is stored in A0, 3 in A1, 4 in A2, 5 in A3. Right? So for this higher level, every time we have a call, this thing, assembly will create a new version of that one. So whatever the values are there, they're going to be passed into registers. Next time you say 8, 9, 11, 12. So it will be 8, 9, 11, 12. So first value into A0. Now I don't need to repeat this, right? The assignment of 32-bit value is something like this, 0 register. We just added 2, mean this is 2. 2 here, 3 here, 4 here, 5 here. When we do this, it saves the next instruction address in RA, and we jump to diff of sums. Here is diff of sums. So the very first instruction is, what is it? It first need to bring all those. So A0 has first argument, A1 second argument. So we kind of do direct run operation, add on two of those and put the output in T0. Similarly, we do this A2, A3, put the output in T1. Then we use subtract instruction to subtract this T0 minus T1. So T0, T1 we subtract and output we put as 3. Okay, that's it. It calculated here the value in as 3. Now we have to return this result value. So this function has to put this result somewhere so that when it returns, this main knows that where it is located, so I can bring it from here. So we need to create some alignment between them. So this main expects that the return value will always be in A0. That's kind of a handshake mechanism already done. Similar to the arguments will be passed into this register A0 to 7, but we have 4, so we are doing only 4. The return value will be in A0. We can later look into, okay, what if there are, array or something like that, what happens? But right now, one value return. Okay, so this instruction is going to write S3 value into A0. So what do we do now? Now this is finished. Now we need to go back to the next instruction, right? So when we go back, JR takes the address from RA, goes to the next one. Of course, program needs to, when we figure this one, this execution finishes, Y contains the value because it has already A0 there. So we will look further into kind of the further combination of these JAL and JR, what exactly some of those things are done. So these are called pseudo instruction, right? These are higher level instructions. Even though these are assembly language, but they're still like a high level assembly instructions. Make sense so far? All right. What if arguments are more than 8? So what if these values are more than 8? So we are going to use stack for that. So in the next video, we will first study stack, and then we will update our function. We'll create some more values here, and we'll see how we can pass values to the stack and get values from stack and stuff like that. Okay, let's finish this video here and see you tomorrow.